Hi, and I know that some of you struggled with the worksheet that was due in class today, last night over for homework, and I asked my seventh hour if they wanted a video answer key for me going through each of them, each of the problems, and I said absolutely I can do that. Or they wanted it, so I'm going to do that, and that's what I'm doing right now. Now I'm simply babbling, so here we go. In terms of the first section, I feel like most of you probably got that, so I'm going to do this one pretty quickly. The way that I looked at it, or the way that I had my students look at it, was they simply were to go to the periodic table and identify if it's a metal or a nonmetal, and then that really gives them a lot of information in terms of what type of bond is present. So here I have calcium, which I know to be a metal, and here I have chlorine, which is on the right side of the periodic table. I know that to be a nonmetal. So that means that this is going to be an ionic bond. And the reasoning that you could write, what I told my students was they could write metal and nonmetal. Oops. What I know other teachers were saying, they were saying something just as simple as calcium metal is present. So I'm going to pause my video here and I'm going to kind of fill in the rest of these and then I'll quickly talk through them. So if you're still working on this worksheet, this would be a good opportunity to fill in this section. Okay, so I went through and I filled in the rest of this chart. Carbon is a nonmetal. Hydrogen is also a nonmetal, even though it's a tricky little one that appears to be on the metal side. So that makes it two nonmetals, so it's covalent. And so you could say nonmetal or nonmetal, or no metal is present. SN and F3. SN is tin, it's a metal. Fluorine is a nonmetal. So a metal and a nonmetal makes it ionic. You could have also written tin, metal is present. Mg3N2. Mg is a metal, and nitrogen N is a nonmetal. That makes it an ionic compound. It's a metal and a nonmetal are present, or you could say magnesium metal is present. The last one in this section is Ni3. Those are two nonmetals, and that makes it a covalent compound. You could say nonmetal and nonmetal would be your reasoning, or there's no metal present. So that's that first section. And if you have any other questions about that, go ahead and reach out to your teacher. But hopefully that cleared up any questions. All right, the next section here, you are drawing Lewis dot structures for single elements. And you may recall from the periodic table lesson on Tuesday that we gave you the location of, or we gave you the charge for each column on the periodic table. But we also gave you the number of valence electrons for each column on the periodic table. So I'm going to go through and kind of fill these things in for you. I know that potassium is in the first column and it has one valence electron. And so I'm going to go down the list. Calcium is in the second column and it has two valence electrons. Boron is in the 13th column and it has three valence electrons. Phosphorus is in the 15th column, so it has five valence electrons. And selenium is in the 16th column and it has six valence electrons. And when we write Lewis dot structures, what we're really doing is we're really taking the elemental symbol and then we're placing electrons around the elemental symbol that represent the number of valence electrons. And the way that I usually do it is top, bottom, left, right, top, bottom, left, right. There's more than one way to do this, but that's the way that I usually do it, and that's kind of how I'm going to show you. So in the case of potassium with the one valence electron, I'm going to take the symbol, which is K, and I'm going to put its one valence electron right on top, just like that. Calcium has a symbol of Ca, and it has two valence electrons, so I'm going to put one on top and one on the bottom. Boron falls in that nonmetal category. Well, actually, it's a metalloid. It's kind of weird, but I'm going to call it so I'm going to make it a nonmetal. And boron has three valence electrons, top, bottom, and then I'm going to go to the left. Phosphorus is also a nonmetal, and it has five valence electrons, so it's going to go top, bottom, left, right, and then I'm going to double it up. Now the trick here is that you don't double up electrons until you have one on each side of the symbol. Lastly, we have selenium, and selenium has 6 valence electrons, and so if I'm following my pattern, top, bottom, left, right, top, bottom, and so that's how I do it. Like I said, there's more than one way to do these, but that's the procedure and the way that I do it. Again, if you have any questions about this part, consult your teacher or reach out to your teacher and they'll help you out. So now we're going to go to the part where I know many people struggled. And so I'm going to kind of go through this one, these individually, and I'll spend some more time on these than I did on the stuff on the first page. So first thing I'm going to do is I'm going to look at the elements that I've been given and identify if they're a metal or a nonmetal. Strontium is in the second column on the left side of the periodic table, so I know that it's a metal. Bromine is in the 17th column on the periodic table on the right side, so I know that it's a nonmetal. So that automatically tells me it's an ionic compound or it's an ionic bond, so I'm going to have to follow the transfer rules. Strontium has 2 valence electrons because of where it's located, and bromine has 7 valence electrons because of where it's located on the periodic table. So the first step that we're going to do is we are going to go ahead and we're going to draw our elements, so the Lewis dot structure. So I'm going to take SR and I'm going to add the valence electrons, 1, 2, and I'm going to take bromine and I'm going to add those valence electrons, 1, 2, 3, 4, 5, 6, 7. Now, the next thing I'm going to do is I'm going to show transfer, and I'm going to show transfer by drawing an arrow indicating that an electron was given from a metal to a nonmetal. And that's something that we have to remember with all of these is that electrons are transferred from a metal to a nonmetal. And it doesn't go the other way. So we don't go nonmetal to metal. So I'm going to show a transfer by having one of these electrons come over here. And actually, I'm going to erase this dot and this dot on the metal, and I'm going to make it an X. That's what I was doing in my classes, so that I can track where things are going. So now I've transferred 1 electron from strontium to this barium, and I'm going to go over here, and I'm going to write the resultant ion over here. So I'm going to write bromine rather, and I'm going to write the electrons that it had. It was the top, bottom, left, right, top, bottom, left, and then I'm going to add that X right there. So now bromine has the 8 valence electrons that it needs. Strontium, on the other hand, over here still has an electron associated with it, and we can't leave it that way. So I'm going to add another atom, and I can only add strontium or barium. And we don't want to add a metal because we don't want to give electrons to a metal. And we know that electrons transfer from metal to nonmetal, so that means in this case, I'm going to add another bromine. And I'm going to start with its original 7, 1, top, bottom, left, right, top, bottom, left. And then I'm going to transfer this second electron from strontium to bromine over here. So now my second bromine, right, has 8 valence electrons again. So it's top, bottom, left, right, top, bottom, left, and there's the one that was transferred from strontium. So now I'm going to bring my strontium over here and I'm going to clean that up. And so now I've created a pattern. It's like bromine, strontium, bromine. So I'm kind of trying to create some type of a pattern here. Now, the other thing that I need to do is I need to add charge. Strontium lost 2 electrons, and if it lost 2 electrons, that means that its charge is going to become +2. Bromine, an individual bromine gained 1 electron, so its charge is going to be -1, twice. Okay. And in this instance here, so I've got strontium, which has no dots, and I've got bromine, which has got all the dots. So another way to look at it is in terms of a check is that, is the metal naked? Lost its outer layer of clothes? And is the nonmetal fully clothed? That is, does it have 8 valence electrons? And in this case, our nonmetals all have 8 valence electrons. They're good to go. And the metal doesn't have any valence electrons. Well, it technically does, but it lost the ones that were in its valence shell. So now the last thing we have to do is we have to count up the individual atoms. So I see that I have a strontium followed by a bromine. And in this instance here, there's 1 strontium for every 2 bromines. And so there's going to be my chemical formula. I always want to write my metal first, nonmetal second. So that's the first one. And I'm going to go through the next 3, maybe a little bit quicker. But I hope that this is helping. So here I have lithium, which I know to be a metal. And nitrogen, I know to be a nonmetal. I know that lithium has 1 valence electron because of its location on the periodic table, and nitrogen has 5 valence electrons because of its location on the periodic table. So I'm going to start with 1 lithium, and it's 1 valence electron. And I'm going to start with 1 nitrogen, and it's 5 valence electrons, top, bottom, left, right, and then I'm going to double up on the top. I'm going to go and show transfer of electrons. So I'm going to transfer 1 electron to nitrogen. And at this point, my lithium has become naked. The metal is naked. So that's good for the lithium. So I'm going to put that over here, Li, and it lost 1 electron, so its charge is +1. The nitrogen, however, has 1, 2, 3, 4, 5. Now it has 6 because it gained 1 electron. It's not fully clothed. It doesn't have 8 electrons. So we need to add something. And I'm not going to add a nitrogen because I don't want to add a nonmetal to a nonmetal, but I am going to add another lithium here with 1 valence electron. And now I'm going to show transfer. So this one I'm going to place here. So now I have a second lithium atom that has lost all of its electrons and it's naked, for lack of a better term. So I have another lithium atom that's going to have, an Li, and it's going to be a +1. But at this point, my nitrogen has 1, 2, 3, 4, 5, 6. It has 7 electrons. It doesn't have the full 8 yet. So I have to add another element, and this time I'm going to add lithium with its 1 valence electron, and I'm going to transfer it here. So now I've got a nitrogen, right, that has its original electrons, top, bottom, left, right, top, and it has 3 electrons that were transferred to it from 3 lithium ions. Okay. And in this instance here, I've now got 3 lithium ions. I now have 3 lithium ions, each losing 1 electron, so they each have a charge of +1. My nitrogen ion has its 5 original, and it gained 3, so its charge is a 3-. And I just tried to set them up so that they look like they are creating some type of a pattern, or at least it looks like they're near each other where they were bonding. So now I'm going to go ahead and write my formula, and I see that I have lithium comes first because it's a metal, and nitrogen comes second. And in this case, I have 3 lithiums, so it's going to be Li3N, and that's the second one. The next one is iron and oxygen, and I know that iron is my metal, and I've been told that it has 3 valence electrons. So that's pretty important there because iron is a transition metal, and we don't know the number of valence electrons for that. Oxygen is my nonmetal, and according to oxygen's location on the periodic table, that has 6 valence electrons. So I'm going to start by drawing 1 iron with its 3 valence electrons. And I'm going to draw 1 oxygen with its 6 valence electrons. Top, bottom, left, right, and I'm going to double up the top and the bottom. The next thing I'm going to do is I'm going to show transfer. So one of these electrons from iron is going to go to this oxygen, and one of the electrons from iron is going to go to this oxygen. Doesn't matter which one. No, it just has to transfer. Right now, I can tell that my oxygen has picked up 2 electrons, so my oxygen now has 8 electrons. It's fully clothed. Top, bottom, left, right, top, bottom, and then the 2 electrons from iron. So if it picked up 2 electrons, that means that its total charge is going to be a -2. My iron, on the other hand, has 1 electron left, and it's not completely naked, so I need to do something. And I'm not going to add an iron at this point because adding an iron to an iron doesn't make a lot of sense. So I'm going to add an oxygen with its 6 valence electrons. So top, bottom, left, right, top, bottom. And I'm going to show transfer of the remaining electron on iron over here. Now, my first iron that I drew is in good shape. It's lost all of its electrons, so I can write it over here as the result as Fe, and it lost 3 electrons, so it's going to have a charge of +3. But I have an oxygen now that only has 7 electrons and needs 1 more, and the only thing I can add at this point, like I wouldn't add an oxygen to an oxygen, so I can add an iron to an oxygen with its 3 electrons, top, bottom, left. I'm going to show transfer of 1 iron electron over to this oxygen here. And now I have a second oxygen atom that has 6 valence electrons of its own. And it has now picked up 2 more electrons from iron. So that atom has gained 2 electrons, so its charge is -2. I have an iron that has not lost all of its electrons yet, so that's not good for it. So I'm going to add an oxygen here, and I'm going to have 1, 2, 3, 4, 5, 6, and then I'm going to show transfer of the remaining electrons. 1 is going to go on this side, and 1 is going to go on this side. Okay. Now my second iron has lost all 3 of its electrons, so it's pretty satisfied. And my third oxygen has gained enough electrons to have 8 electrons or be totally clothed. Bottom, left, right, top, bottom, left, right. I'll do it this way. Okay, there. So now it has gained 2 electrons, so its charge is going to be a -2. Now, look, I've made this sort of repeating pattern. Oxygen, iron, oxygen, iron, oxygen, iron, and that's kind of what we're going for there. When I rewrite this formula, I'm going to write iron first, followed by oxygen. I see that I have 2 irons for every 3 oxygens. And so that's the third one. The last one is MgS. And so I know that Mg is a metal, and I know that sulfur is a nonmetal. I know that the location on the periodic table tells me magnesium has 2 valence electrons, and the location on the periodic table tells me that sulfur has 6 valence electrons. So I'm going to start by writing or drawing a magnesium atom with 2 valence electrons, top, bottom, and a sulfur atom with 6 valence electrons, top, bottom, left, right, top, bottom. Now I'm going to show a transfer from metal to nonmetal. So 1 electron is going to go here, and 1 electron is going to go here. And at this point, my magnesium metal ends up being losing all of its electrons or being naked. It lost 2 electrons, which means it's going to have a charge of +2. My sulfur is fully clothed. It has gained 2 electrons to its original 6. Something like that. And so now the sulfur has a charge of -2. Now when I write this compound, I'm going to count them up. So I have Mg and S. And so it'd be like Mg1, S1, because that's really what we have here. But we don't write ones in chemistry, so we're just going to simply write Mg and S, and then that's our final answer. I hope that this clears some things up for those of you that have been struggling with this particular the electron transfer stuff. If you have any further questions after watching this video, please let me know, or your teachers know. Otherwise, good luck, and we'll talk to you later.